Hey everybody, we are continuing 3-4 on the homework. This is starting with number 2. Now, as a reminder, this is 3.4.3. And so, if you're referring to my previous video, it's like this one where we had to do T of 3 and then did all this work. Kind of like the last question. So with yours, we're doing, first step is our interval is 0 to 5. And so we're doing S of 5. So you can either plug it in manually like this, or you can like type that as negative x cubed plus 3x squared minus 3x, and then look in your table. Those are the two ways to do it. Since I only have to do this once for that, I'm just going to keep it like that. So negative 5 to the third power plus 3 times 5 squared minus 3 times 5. Negative 5 to the third power plus 3 times 5 squared minus 3 times 5. Okay, so when you do that, you get negative 65, which is that answer. Then the next part, it wants average velocity. And so you do your delta S over delta T. So you're changing the distance, which is S, is negative 65. Your change in time is 5 because you did 5 minus 0. And so when you do that, you get your negative 13, which is that answer. Now, remember that when we're doing speed, speed is never negative. So it's not just this question, but many. Make sure your speed is positive. Okay. Now we need the speed at t equals 0. So the first step would be if s is negative t cubed plus 3t squared minus 3t, then your velocity, which is your s prime, is negative 3t squared plus 6t minus 3. So then at t equals 0, it's just going to be the absolute value of your velocity, which would be 3. So it's like, if you wanted me to write another step, it's speed. I was going to put s, but forgot s's distance. It's the absolute value of negative 3, because this would be 0, and so would this. So that's how you get your 3. And then at t equal 5, you would do negative 3 times 5 squared plus 6 times 5 minus 3. This time I'm going to graph it. Because I know I'm going to need that graph later on. And that'll just save time. So negative 3x squared plus 6x minus 3. Okay, there's my graph, and what we care about is at 5. So I go Control T and go down to 5, and I get negative 48. So I get the velocity of 5 is negative 48, and you do the absolute value of negative 48, which is 48. So that one in particular, remember, same thing, speed is never negative. So your speed answers should both be positive. Okay. And then for the acceleration, we do the derivative of the velocity. So we take our negative 3 times 2 is negative 6 x, and then plus 6. And then we plug in 0 here. So 0 plus 6 is 6. So that's how they get that. Because we're doing at 0. And then at this one, we're doing 5. So we do negative 6 times 5 plus 6. Negative 30 plus 6 is negative 24. So then for the next part, we need to check where it changes direction. Remember, sometimes it is going to change direction. That's if you have one positive, one negative. But it doesn't if both are positive or both are negative. So what we need to do is first set v of t equal to 0, and basically you could say, or look at the x-intercept, because we did graph it earlier, and so I can see from the table one of them's at 1. I guess that's the only one. Yeah. So it's 1, 0. Because your graph looked like that. And then we do negative 3 times 0 squared plus 6 times 0 plus 6. That gives me 6, which is positive. And we're talking about the whole interval, so we're looking at 5 also. Negative 3 times 5 squared plus 6 times 5 plus 6. Oops. Negative 3 times 5 squared plus 6 times 5 plus 6. That gave me negative 39. Hold on just a second. I'm going to pause this just for a second. Okay. I think what I did wrong just right there was I plugged into the wrong equation. I should have plugged into the acceleration. So negative 6 times 0 plus 6 is 6. And then negative 6 times 5 plus 6. That's negative 24. Okay, so scratch that also. What I just realized is on this one, from here to here, there's no place like home. No, there's no place where the velocity was above the x-axis. So that means it's no change in direction. So that's why this one is no solution, because it was below. And so just to wrap that up, this part was okay. What I did wrong was this was -3 at the end. And I had written like from an example that had +6. So the +6 part was wrong. And so if you plugged in 0, you would have gotten -3, which is negative. And if you would have plugged in a -3 here, you would have gotten -48. And since both are negative, no change in direction. So you can do it both ways. I just had done a little simple mistake. Okay, now let's go on to 3. So 3 is like my number 5 over here. Again, these are pretty long problems. That's why there's only a few over here. So it's the same process, basically. We're first going to do your change of S. We're going from 1 to 5 this time. And so on this one, you know what? I'm going to keep this very simple. I'm going to call F1 equal to 25 over x squared minus 25 over x. And I want S of 1 and S of 5. I'm going to get that from the table. If you use your table, you shouldn't make a sign mistake, hopefully. So let's do that. 25 over x squared minus 25 over x. Okay, so there it is. And in my table, at 1 it's 0, and at 5 it's -4. Okay, so as we were saying, if you use your table for these, you get 0 and you get -4. But what I just noticed, because I was doing this real fast before the bell, is this one should have just been 5 over x. So 25 over x squared minus 5 over x. So that's correct now. And so then when we go to our table, for 1 it should have been 20. And for 5 it should be 0. And so then you do S of 5 minus S of 1, because it's right minus left, left, right, right minus left. And so then that's 0 minus 20 is -20, and that's what they got. Then for the next one, you have your velocity, and so that'd be your first do 5 minus 1 is 4 for your seconds, and you do -20 divided by 4 is -5. That's how you get that. Now remember, for the speeds must be positive. And it's talking about the left and right endpoints of the interval. So the first step would be figure out what your velocity is, find velocity, and then do the absolute value. Okay, so if that's your equation for your S, I'm going to write that as 25t to the -2 minus 5t to the -1. So for the velocity, which is S prime, you're going to do -2 times 50 is sorry, negative 2 times 25 is negative 50 t cubed, really to the negative 3, and then plus 5t to the negative 2. So then we need to plug in v of 1 and v of 5. So 1 would be easy. It's just going to be negative 50 plus 5 is negative 45. And then we said do the absolute value. And so that's 45, which is that one. And for v of 5, I'm going to use the calculator. It's negative 50 and then 5 to the negative 3 power plus 5 to the negative 5 power. Wait, 5 times 5 to the negative 2 power. Okay, so let's type that. Negative 50 times 5 to the negative 3 plus 5 times 5 to the negative 2. That gives me negative 1/5. And the absolute value of negative 1/5 is positive 1/5, which is why that's the answer. Now for the accelerations, remember accelerations could be positive or negative. So the acceleration is the same as the derivative of the velocity. And so you do negative 50 times negative 3, which should be positive 150 t to the negative 4. And then 5 times negative 2 is negative 10 t to the negative 3. And again, it's talking about the left and right endpoints. So the acceleration at 1 would be 150 minus 10, which is 140. And that's that answer. And then the acceleration at 5 would be 150 times 5 to the negative 4 minus 10 times 5 to the negative 3. So 150 times 5 to the negative 4 minus 10 times 5 to the negative 3. That gives you 4 over 25, which is that answer. Then about the changing direction, let's do it like we did before. Graph the velocity. So negative 50 x to the negative 3 plus 5 x to the negative 2. Okay, and we care about the right side because we care about between 1 and 5. And I'm getting that it's like this. And so it's never positive. And so no change in direction. So that's that. So that did match 3, 4A. Now on this one, this one's a little bit different. It's 3.4.7. And so that corresponds to my number 7 on my other part. So you've got a few parts to do. The only confusing part was the back part a little bit. But here's how you do it. The start of it is It's right there. I have negative t cubed plus 6t squared minus 9t for my distance. And it wants the acceleration each time it's 0 for the velocity. And so the first thing you do is find your velocity. And so you take your derivative of the distance. So you do minus times 3 is negative 3, t, and lower it a power. Then you do plus 6 times 2 is 12, and lower it a power to just t. And then negative 9 is what you have left there. Now you want to factor out your common factor, like your greatest common factor. And since it's 3, 12, and 9, I can factor out a 3. Depending on your numbers, sometimes you might have to factor out a 2 instead. So you go ahead and do that, and so 0 over negative 3 cancels to 0. And then, negative 3t squared divided by negative 3 is t squared. 12t divided by negative 3 is negative 4t. And negative 9 divided by negative 3 is positive 3. The other way is you can just multiply to check. Negative 3 times t squared is negative 3t squared. Negative 3 times negative 4t is plus 12t. And negative 3 times 3 is negative 9. So once you have that, then you set it equal to 0. And this one's easy to factor. So if I have t squared minus 4t plus 3, you factor it into t minus 3 and t minus 1. And so that means we're interested in 3 and 1. Now, that didn't mean your answers are 3 and 1, because obviously they're not. What you do then is you do a of 1 and a of 3. So before we can do a of anything, we have to find it. And so we have to do our derivative of this part. Derivative of the velocity function. So negative 3 times 2 is negative 6t. And then since this is plus 12t, then this is plus 12. And the derivative of any constant is 0, so we don't care. Then you plug in your 1 to the t. So you have negative 6 times 1 plus 12 is 6. And this one, plugging in 3 for a. So negative 6 times 3 is negative 18, plus 12 is negative 6. And so that's how you get these answers. So that's from this one and this one. The next part is you want your speed. And so if we start with our negative 6t plus 12, set it equal to 0, and then just solve, and you get 2. It's 2 seconds. Now, that's not this answer because that's 3 meters per second. So what we did is we just found where the speed was 0. Then you have to plug that 2 in to your velocity. And also, since it's speed, it has to be positive. So we do negative 3 times 2 squared plus 12 times 2 minus 9. And so you end up getting 3. And so 3 is your answer. Now, for this last part of it, it wants the total distance traveled from 0 to 2. And so you first want to use your velocity graph, and we need where it's above the x-axis. We're interested in 0 to 2 overall. Here I just made some notes. It was decreasing from negative infinity to 1. Now this is different than any other decreasing we've talked about before. This is about the velocity decreasing, and not just like, oh, it's up, so it's increasing. Because that's what I would have thought, and that's why this was a little harder. But the decreasing is anything below the x-axis is decreasing. and anything above the x-axis is increasing. So that's why this is different from anything we've ever done before. Okay, so when I looked at the view and example, I see the formula we need to use, which is the original one. And I need my displacement on 0 to 1, which should be negative. And I need my displacement on 1 to 2, which should be positive. And so let's do that. We plug in 1 for t, so we get negative 1 cubed plus 6 times 1 squared minus 9 times 1. And then because we're plugging in 0 and all of these have t in it, that meant t had to be 0. So when you do this left side, you get negative 4, and then minus 0 is still negative 4. And don't change it to positive. Okay? This is like a total distance. It's not the net distance. So you went 4 meters, whatever you want to call it, left or down, because it's negative. And on this one, you're doing your displacement from 1 to 2. So you do your right side here, f of 2, minus this side is f of 1. So we do our negative 2 cubed plus 6 times 2 squared minus 9 times 2. When you do that, you get negative 2, and then minus, and then we already knew this side was negative 4 from when we did it here. I don't know why I wrote it down again, but that's the same as that. So minus a negative 4. Now, negative 2 minus a negative 4 is like 2, because that's negative 2 plus 4. Now, for your total distance, we needed to do the absolute value of negative 4, which is 4, and then the absolute value of 2 is 2. 4 plus 2 gives you 6. And so you had to do your absolute value of the negative one. Do the absolute value of the negative distance and add to the positive distance. And that's how we got 6, which is my answer. Okay. Now, this next one is actually probably easier than you think. It's 349. On mine, on the book, it talked about Mars and Jupiter, but on yours, it just says on a planet. What we first do is our derivative. So we need 6.37 times 2. And so 6.37 times 2 is 12.74. And then you plug in your t. No, you're looking for t. Sorry about that. And we want our velocity. .4 to be plugged in for the v, and then we divide. So you do 24.4 divided by 12.74, and that's 1.915, and they want to the 10th, and so 1.9. So based on this, they round down to just 1.9. Okay. And then on this one, this is number 11. It's kind of related to this one. Finding gravity on a small airless planet. You have a launch velocity, a distance formula, velocity, and then given that the max height was after a certain number of seconds, find g. and that's what we do here. So on yours, we have S equal 13t minus, I'm going to put 0.5 because that's easier for me, at least on the calculator it is. And this is gt squared. So then my velocity, which would be s prime, would be 13 minus 0.5 times 2 is 1. So you just get gt. So now, given that the max height was 20 seconds after, then we're going to do v of 20. And so we have 13 minus 20g. And there we have to set it equal to 0 because whenever it's a maximum height, then it stops for a second. Well, not literally. It stops for an instant. And so that's when the velocity is 0 at the max. And so then we say 13 equal 20g because we add 20g and then divide by 20. And so then you're doing 13 divided by 20 as a decimal, and I get 0.65. So that's your answer. Okay, so your next problem is like my number 15. 13 was like a free fall from the Tower of Pisa, but we didn't do that. You're doing 15, which is understanding motion from graphs. And so you basically are going to be given a graph. It reverses direction when you have an x-intercept. It has a constant speed when it's flat, and graphing speed can't be negative. And so you basically flip it upside down to like that. So let's catch up for your problem. What we first do is get our x-intercepts. So that's the 2 and the 4. So that's these answers. And then the constant speed would be from here to here. That's our constant speed. And so that's your 5 to 8. And so that's these answers. Then for the speed, it can't be negative. Can't be negative. Just like on the other problems, we said it must be positive. And so basically what you do is if you want to like draw it like a triangle for that part and then, or like an angle, and then flip it up. Whoops, that, and then you're going to have a horizontal line. Okay, this, and then your horizontal line, and then this is going down on the right side. So that's this graph. So you have your 2 upright parts, and then you have your like part that kind of looks like a quadrilateral or a trapezoid in this case, but it's not really connected, whatever. So that's the right graph. So the thing was flip across, well, flip any negative part across the x-axis. Leave all positive parts positive. So you're not technically reflecting across the x-axis except for this part right there. Okay? And then for this part, it's kind of like what we did before, I think. You're going from 0 to 1, and your point is up here. Looks like that's at 4. And so you're going to have a horizontal line at 4. That was right. And then it's decreasing, and so then you're going to have one at -4. And then you're going to have another one at 4 and another one at -4. Four, -4, 4, 4, -4, 4. I don't see the other part down here. It seems like it should be. And then the flat part should be at 0. Flat part at the x-axis, y = 0. And then this was negative slope, and so this is down. That looks like it's down 2. Okay, so that's that graph. Okay, and then for the last one, you have this graph. Now, these are kind of small boxes, so you got to read that really carefully because you're counting by something kind of weird. I think you're counting by tens. Yeah. So your Y scale in my case is 10. And like on mine from the book, my maximum point was at 2,190. And so how fast it was burning when the engine stopped was 190, because that's your Y value. And then the seconds corresponding with that is it burned for 2 seconds. So if we relate that to yours, this is also 2,190. And so the 190 is the Y answer, and then the 2 is the X answer. Y of the max, X of the max. Okay. And then the next part says, when did the rocket reach the highest point? The highest point is when your velocity is 0. And what was the velocity then? Okay, so the highest point is when the velocity equals 0. Now, here's the tricky part. Most of your graphs have the x-axis down here, but you can see that's -100. But on yours, it's like right here, and so it's kind of like right there. It's like right there at 8, because that's 80. And so this is your x-intercept, and this has to be 0 because it's on the, well, it's the Y value on the x-axis. Okay, then it wants to know about when the parachute pops out. And so that's when you got to go between these. And now for the X scale, it's kind of weird. You know, when we were talking about Y scale being 10, well, this one's also weird because it looks like 1 would be there, 0.25, point, no. 0.2, 0.4, 0.6, 0.8. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So the tricky part, like on that, was the X scale. And when I did mine a long time ago, I had 10, and then I had another line that was at 10.4. Another line was at 10.8, which was my answer. And then I had 11.2, and then I had 11.6, and then I had 12. So that is pretty tricky right there. But mine was at 10.8, because this one's 10.4. And so that's how you get this answer. So it's the minimum. Now, the other part about this is if you were being, like figuring out your ordered pair, you'd say 10.8 comma negative 90. But fast has to do with speed. So we need the absolute value of negative 90, which is 90. Because remember, speed can't be negative. Can't be negative. You can't go negative 90 feet per second. You could go 90 feet per second. Just like you can't go negative 30 miles an hour. And then they want to know how far or how long the rocket fell before the parachute opened. And so for that one, look for the max on the graph. Wait, I messed up. On this one, we do 10.8 minus 8. And that's how we get 2.8. So that's basically from your point here, 10.8 minus 8. So it's like once your velocity was 0, then the chute started, you pulled the cord there, it took a little bit, and then it started responding and opening. It took 2.8 seconds to open. Okay. And then the greatest acceleration happened 2 seconds after launch, because it was the max, 2 comma 190, and it's the X value. And then acceleration was constant when it was on the slanted line. And so that was between 2 and 10.8, because these are your X values. And then this answer should always be negative 32. So what you do, I think, is do velocity of 10.8 minus velocity of 2 over 10.8 minus 2. So you get negative 90 minus 190 over 8.8. And when you do that, you get negative 31.8. And so that's to the integer, negative 32. Okay, got that video done. I hope that helps. Have a good day.